Well, thanks, Amy. That was very interesting. I've not heard of pizza nodes before. I don't know about anyone else, but I'm going to try and remove the capers from mine. That was very interesting. There's certainly a lot to unpack there. Does anyone have any questions? Oh, we've got straight in there. Yes. Can you get a microphone to this man?
Oh, hi, Amy. Thanks a lot for your amazing talk. So I'm Paddy Yan. I do mathematics at Cambridge. I've got two questions for you. The first one is that, in mathematics, there's a sort of development of graph theory since the early 1900s, and things like Ramsey theory in the 1920s and 1930s. I wonder, in all of these modern sort of data science we have, all of this data, they seem to be using rather simple consequences from the pure math in 1920s. So are there breakthroughs in the mathematical side of graph theory, let's say in recent decades, that you think have the potential to be utilized in data science? That's my first question. And the second question is more general, actually. You touched base on that at the last few slides. I think, at least as a mathematician, that there are always some problems from an academic perspective, from academia perspective, to communicate with people in the application world or people in the industry. And they seem to persist all the time. So I wonder if there's any bits and pieces of techniques you could share with us that how people from the academic world could contribute better or communicate better to the people in the application or industry. Thank you.
Thanks, good question. Well, first I'll say I'm not a mathematician, so I'm probably not as up on the research as you are, but there was, I think it was in June, it might be around that, Spielman and Tang came out with a new algorithm for network flows that is supposed to be, in their terms, wicked fast. There's a really great article on Quanta magazine on it. So Quanta magazine is they usually do a lot of early research exposure, and they have a mathematics and a graph section as well. And that one it might sound like, well, I thought we had already kind of figured out flows. But the traditional flow algorithms, as you probably know, are really slow. And they're really computationally intense. And so for the rest of you, the flow algorithms, you use it for like traffic scheduling. I was actually going to talk about flow in financial contagion as well. It's like worst case scenario. It's like how fast can this ripple through a network? But what's I think slowed us down a little bit, even in supply chain, is just the algorithms aren't very performant. But the Spielman-Tang seems really promising. But it's too early to see that in production. The other question about interaction with academic and business, I would love to see more of that, and I actually would like to see it. I don't think it's just academics doing better with business. I think it has to go the other way as well. So I would love to see more businesses fund and participate in academic conferences like SIG-KDD and NeurIPS and things like that, so that we can kind of bring those two communities together. I guess that's one area. The other thing with communications is perhaps also academics joining some of the more commercial conferences as well, and kind of speaking and talking there. I guess the third thing with the academic is I would love to see more academic research on real-world data, because it does have a tendency to be really messy. I talked to one researcher who was telling me how great this new algorithm was, but it was terrible with noisy data. I'm like, all right, I can't do anything with that, because that's all I have is noisy data. So I think just like using real-world data sets and just finding out where the problems are and how we can make them better. But thanks for the question, yeah.
Yes, you're right there, why not?
Hello, my name is Nikita Koshev. Well, I'm autistic, so if I insult anybody, just tell me. I make magic happen using open source, and that's one of the things. Well, I can make any person a contributor to open source in 5 minutes' time. That's the easy part. One of the things which has happened, except the math in the last years, is the open source, where you can literally contribute to any quality project quite fast. And I know that two big companies are G-Research in open source, like really big. You can compare them to Google, and Neo4j. My question to Amy will be, what are your, if they exist, what are your favorite projects in open source? And do you have any, especially in graphs, and do you have any, I don't know, suggestions for the audience, how they can start in graphs in open source? Because like, instead of doing home exercise in Hello World, you can start doing real stuff this evening.
Yeah, so thanks. And I would encourage people to play with graphs, test out things. There's a lot of open source or open projects out there, so you can kind of get started and get your hands. And I will say, I find people who are interested in graph, well, one, they're just really cool usually, but they're also willing to help each other out. And maybe it's something about understanding that connections are important. But so I would definitely recommend that. One of the projects that I do think is really interesting is the COVID graph project. COVID graph, you can Google it. And you know, participating in that is kind of a obviously very timely and important thing. And I think the work there is going to help with more than just COVID and trying to get, how do you get this amount of, especially these last couple of years, the amount of data that's been coming in and tracked and then do things with it. And I suspect they're probably gonna need help for many years as they try to interpret what's going on. So that's just one project, but I'm sure you can find many others out there.
I think there's been quite a few other interesting projects that have real-world basis in graphs, hasn't there? Things like connecting people after a hurricane and things like that with interesting things. Have you heard of any other interesting ones?
I think that's, you know, like you said, there's so many out there. It's kind of hard to, you know, choose just one. I don't know if you've got one on your mind that you're thinking of?
I was thinking of some tornado in America took down all the power lines and they connected people with support and things. It was quite interesting. But I imagine there'll always be projects like that people can help out with if they want to.
Well, and definitely, and if you're interested in that, you know, definitely even starting your own projects, if, you know, for those, you know, for that kind of work is definitely something that I think can bring a community together.
Do you have any other questions? Yes, in the middle.
Thank you, Amy, for the great talk. My name is Anna Grabenskova, and I have a question that's a bit finance related. Have you looked at how insights on financial contagion compared to the conclusion on risk diversification that were made on asset-backed securities and mortgage-backed securities around 2006 to 2009? Because we now know that the supposed diversification did not work at all. But has anybody really looked at from the point of view of graph network theory? And would that have shown the obvious problems that we now know that were all over those, you know, ABS stacks? And if we look at the current credit stacks that are being traded, would you see similar problems?
That is a very specific question. Wow.
Very important one to a lot of traders.
Well, so I'm not sure if I can answer it satisfactorily for all the aspects. But what I will say is, well, again, I'm not a financial analysis, so I have not, and I have not read of that analysis specifically with graph. But I will say I do know that there are banks out there that are looking at risk portfolio analysis based on, you know, what's in their portfolio and what a little bit of that financial contagion I was talking about, and then also just looking at it from an overall portfolio perspective of, you know, where are the risks, where are the potential connections that we can't see, and trying to look. When I talked about the local contagion, that's kind of a, you know, a personal or a bank, you know, local contagion in their country and where they're invested at. And then your question about, you know, are we setting ourselves up for a similar situation from prior issues? Open question. I'm not an economic professional, but I do think one of the things that we saw in 2008 was the highly interconnected network without a lot of good breaks was partially responsible for how quickly, at least in the US, some of those issues spread. And so I do believe that we need to have some breaks in our systems, and so some limits in how quickly we want information, or in this case, financial distress to spread, and kind of be concerned with that flow. So I think it's a great way to look at it. I think it needs to be done, because we all love connections, but sometimes being overly connected is actually at risk as well.
Hi, thank you very much for a very good talk. So it seems like a lot of the stuff you were talking about this evening can roughly be simplified to, you've got a set of data, you define some sort of similarity between the points in whatever your data set is, and then based on that similarity, you minimize some sort of distance. So when you're defining the similarity, you're giving basically numbers between different points in the data set. Now, that representation of it, just with the numbers, works quite well for a lot of mathematicians. Do you think one of the powers of the graph representation is that it makes it easier for people who maybe don't understand stuff like maths or computer science to start putting or placing their prior knowledge over these issues? Do you think that is what helps this stuff go forward, or is it something more specific to the actual mathematics and the network theory?
Yes. So the first part is, and I will just say, just to remind you, it's not just similarity. That just happens to be one algorithm, or category of algorithms, but that are very, very useful. But I think it is both the mathematics, because beyond just similarity, which is set theory, you also have mathematics that look at, again, like if you're thinking about betweenness centrality, percentage of shortest paths through every node, or the high degree nodes, that actually pull out meaning as well. So I think there is something very special about the maths as well that are really important and reveal things. So if you're doing mathematics to optimize how tightly you think a group should be clustered based on relationships, that is pretty unique. For at least for analytics and where you're looking at your data. So I do think there's something magical about graph algorithms, but to your point about communicating it, I think that is also really important. I've talked to many data scientists who say, this is really great. Now I actually can show with a graph my manager what's going on, especially if you have any kind of visualization, so that you can kind of help. And you can help communicate as a data scientist what you're doing and why what you're doing is important to managers, business, people who fund you. And there's that. And then the other part with graphs and understanding is, depending on what you're using the graph for, a lot of times you can visualize it and then explore intuitively. So if you can explore your graph the way, as most humans are used to looking at things and seeing patterns, you can look at something and use your human brain to augment the graph. I never thought of it that way, but you're actually kind of interacting with it. And I think graphs are just a natural way. How many times have you guys walked up to a whiteboard and you're doing circles and lines? That's a graph. It's what we naturally do. So I think it makes sense that we interpret with it.
If you make your too many circles and lines, though, doesn't it make it, in fact, harder to explore in a way? If you have that big ball of mud, it can seem very daunting sometimes.
It can. So I think when you visualize graphs, it also depends on, you want to think about what you're trying to visualize. So if you're visualizing in the data lineage graph, if you're trying to visualize all of those flows as a graph, you probably have just a big hairy ball of things you couldn't see. But if you're trying to visualize the process of the ETL and the reports, then that's very intuitive. I do think one of the things that I think is kind of a mistake some of us do in the graph world is we assume everything has to look like dots and lines because, ooh, isn't it pretty? And we like that. But if you're looking at like the highest, you just want to find the highest page rank individuals, you actually don't probably want to look at it as a graph. You actually might want to look at it as just some boring tables. But that's okay, because that's what you need. So I think it's a balance as far as what you're looking at. And you can also you can also obscure things that aren't interesting, so you can try to find different patterns. There are some vendors out there that are actually aggregating views, so you'll get something that looks like a big node, but it's actually not a node. It's made up of communities of nodes. And those communities make a mega community, then connect to something else. But if you want to dive in, you can actually dive into them. So it can if you just like blindly throw everything in. Yeah.
Any others? Yes, yellow hoodie.
Hello, thank you, Amy, for your talk. Question a bit more on the lighter side, similar to the dogs at the polling stations. What was kind of the most surprising use case or discovery that you have explored with graphs during your career? I suppose you have seen quite a lot. I think that would be quite interesting to hear.
Yeah, thank you for that question. Actually, somebody else asked me that early today, and it's one of the things that I will always remember because it kind of opened up my thinking about graph algorithms. There were working with some banks that were looking for money laundering in their data, and they noticed these patterns that are very predictive of money laundering. One of the, I think I mentioned it earlier, is these floating islands where people are transacting with each other, but not the rest of the system is very unusual in a financial system. They were looking at it, and what they found when they dived into it wasn't money laundering, it was human trafficking. And since that time, actually talking to somebody from the US federal side of things that was a specialist in human trafficking, actually said the reverse. And she had said, you know, we were looking for human trafficking and we found money laundering. I do not know why those two look the same in a financial network. But that to me, when I heard, well, initially I was blown away, and then when I heard the same thing from the opposite side, I just couldn't, it just really changed the way I was thinking about graph analytics and graphs, because what it says to me is there are fundamental structures in our data that mean things, and they mean things regardless of whether we're talking about you know, bad behavior, you know, with humans, or we're talking about finance. And you know, you might use it for data management, but there's some fundamentals about structure that are predictive, that are telling. And I think getting to that and trying to use that power is just really powerful. So thanks for asking that. Yeah.
We'll do one more. Sure. Checkered shirt. Wait for the microphone.
You should have made him go up and down and up and down.
Yeah. Got to give them some exercise.
Potentially, there could be several things. I guess the fastest and most vibrant sort of academic research in graphs on the West Coast is graph neural networks, and so there, you know, Google and the Stanford group led by Yuri Leskovec are doing lots of stuff on that, and they've been workshops and everything, but. I guess I'm not convinced that that's yet sort of ready. What you just said about graph structures is actually what you really need to do is think very hard about the graph you build, not about what you do to it. Because if you build the right graph, you will be able to run analytics appropriate for it. So when you talk about the making a graph looking for disjoint groups, if you go and look at a paper that Microsoft Research did years ago, they projected out botnets in the same way, because it's highly unusual for accounts to be seen in multiple ASs on the internet. So if you've got so it's a behavioural thing, but you build your graph to find the behaviour. You don't just sort of passively take the graph that you're given and turn it out to do an algorithm. You've actually got to think about the data. And so, I mean, I think that's what I like about your talk, is that actually you haven't been that technical. It's all, for me, it's all about the ideas. The maths is easy, actually. It's sort of, that's not difficult. It's actually,
for some of you, but yeah.
No, but it's actually all about insight. And so I think that's why I think it's been such a great talk. But I guess I'd be interested in if you've got anything to say about what the graph neural network community are doing, because that's kind of like the bleeding edge.
Is that the bleeding edge? I don't know.
That's what they say. I mean, they're sort of...
So I think one of the, and actually I'm going to answer this a little different way. What I'm really excited about right now, kind of the bleeding edge that I'll say the three things I'm super excited about are graph native learning, and which has some tangents to neural network. And I like that because you're actually running understanding and learning in a graph structure, and it has the ability to save transient states, start with a graph, end with a graph. But if you can imagine what it means to save a transient state in, let's say, a deep learning model, that means that we can walk back decisions and we can understand and explain how decisions were made, which is really required if we ever want to get to true responsible AI. So that's one thing that I'm super excited about. The other thing is probably the hottest. I think it's the hottest topic now. I don't know. We can debate on that later, but that's causal inference. So 2018, I think, Judea Pearl did his Book of Why. How many people have read that? You? Okay, I fell in love with that. So if you are into graphs and you're interested in causality, just go buy the book. I don't get any royalty, but it's really quite good. It's basically taking a graph structure and think about those dots and the lines and arrows and using that for causal inference. And then there's been several papers this last few years on NLP with causal inference. And then Microsoft, group of researchers, including Microsoft, put out a paper on causal inference on hypergraphs this year, and they actually got the best paper award at KDD. So there's just, to me, there's a lot of interesting, bubbling interest in that area and people doing things there. And I just think that's so important because that'll help us with explainability, and it'll help us with confounding variables and things like that. So that's a whole area that's interesting. And then the third area is a couple companies that are trying to bridge relational and graph worlds. I actually just joined a company that's doing that. I think there's stickers here.
There's one on the front.
Relational. All right, I've done my job. Relational AI. But what they're trying to do is make graphs not this unusual appendage to the rest of your environment and analytics, and trying to run that so that you can project out different data types, including graph, including tables, and so that they don't have to be quite as separated. So those are kind of the three things, because there's some really cutting edge research, and then there's also kind of practical, how do we bring this to the masses?
How can you be sure with a causality graph that you've really got causality, though? I mean, the phrase we all know is the correlation is not causation. These things are fantastic at finding correlation.
Yeah.
How do you know it's causation?
That is not easy. But I do think that Pearl's model has some insights into, because you are putting business rules or rules into it and forcing things in a certain direction, you can do what-if analysis, and you can you can do more proofs that it's wrong. So I don't know yet. This is cutting-edge stuff. I'm super excited because the idea of actually getting to that is, I think maybe the hope that all of us have that we'll be able to get there. So.
Do you have a final word for the crowd? Anything that you want them to take away?
Increase your betweenus centrality. If it's not your favorite algorithm now, it should be. And I guess just in general, I think, as Andrew was saying a few minutes ago, that we do need, a lot of it's about how we approach the graphs, thinking about the graphs, modeling for our problems, doing query planning for the problems that we have. So graphs are not something you can just pour in like a bucket, press a button, and get some magic answer. You really have to think about the problem that you're trying to solve.
Cool, great.